Okay, so these are the homework questions from independent events. So page 21, number 3. Two single-digit random numbers 0 to 9. So we're working with 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 choices of digits, right? Are selected independently. Find the probability their sum is 7. Oh. Well, you can't really do it with an independence formula. You just have to kind of work it out. So probability sum equals 7 is equal to, well, can anybody tell me how many choices we have in the bottom? Right, 10 times 10, right? 10 choices on the first digit, 10 choices on the last digit. How do we get this to add up to 7? Okay, so 0, 7, because this is going to include 0. This denominator, do you agree it will include 0, 7, and 7, 0? So we have to include it in the numerator. So 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1, 6, 1, 7, 0. So 1, 2, 3, 4, 5, 6, 7, 8 ways. So this is 8 over 100, and that equals 2 over 25. Good? Yeah. It's not so bad. Okay. What did you do? Oh. Oh, interesting. Very good. So, or 8 over 10 times 1 over 10. That's good. Awesome. That makes sense, right? You have 8 choices on the first one and no choice here. So there's only one choice. Awesome. I like that. Thank you. I really like that method, actually. Number 6. A car manufacturing plant has 3 shifts working on the assembly line. The morning okay. Shh. A, B, C. All right. The morning shift, we'll call it A. No, you know what? I'm going to call it morning. And I'm going to call this A. And this one E. Very good. That'll make it easier. Morning shift produces 8% of the 38%. Afternoon produces 34%. And evening produces 8%, 28%. Of their output, so in the morning, 0.03 is defective and 0.97 is good. In the afternoon, 0.02 is defective, 0.98 is good. And in the evening, 0.01 is defective, and 0.99 is good. So, if a vehicle is selected at random from the inventory and found defective, given it's defective, what is the probability it was made on the morning shift? So, the probability it's defective is 0.38 times 0.03, right? This branch plus this branch, 0.34 times 0.02 plus 0.28 times 0.01, and we have to work that out. We'll just work that out right now. 0.021. Okay. Perfect. Thank you. And now, what's the intersection of morning intersection defective is this one. 0.38 times 0.03. So I get 19/35 for an exact answer. What was their answer rounded off? Okay, good. Can you guys do B and C, or do you need me to do B and C? Same thing. Number 12? Oh, somebody wanted 10. Okay, number 10, estimate the probability that at least 2 of the next 10 prime ministers of Canada will be born in the same month. So we have 12 months, right? So we're going to have to do probability at least 2. This is number 12, right? Number 10. Probability at least 2 born in the same month is equal to 1 minus the probability no one born in same month. All different. Okay. All different months. So it's going to be 1 minus what?
1 minus 12p10 all over 12 to the 10, which equals 99.61%. And which is the answer?
Which is a I would oh, here's my calculator. Did you get?
It says approximately 1. It says it's approximately 1. So if you got an answer of 1,
I get this answer.
Yeah, that's right. Because the answer is approximately 1. It's very likely. If you think about the question.
yeah, that's true. You're limiting it to 12 months.
With 10 people, it's very likely.
10 people in this class, we can do the same thing.
And literally everyone has the same. Everyone's in the summer anyways.
Okay, number 12.
Yeah, I know. But you guys are the weird ones. You're born in the dead of winter.
Shh. Find an expression for the probability at least 2 selections from a set of n elements are the same in a random sample of size. Okay. So we want probability at least 2 the same is equal to 1 minus probability all different. So that's going to be 1 minus, we have n to choose from, right? No, m to choose, m distinct elements. Right? So this is the same as 1 minus 1 over, I'm just going to separate this because this is going to be m factorial over m minus n factorial. We use the NPR formula. Right? We're using that formula. And that's the answer, right? Is that okay? Okay, let us now do odds.
The odds are.
Odds, odds, odds. Okay, odds. Odds is another way of expressing probability. The interpretation of odds is the degree of confidence or probability that someone has that an event will occur. The higher the ratio, the greater is the degree of confidence, or the greater is the probability. Odds are most often used in gambling games, at casinos and racetracks, in sports betting and lotteries. Odds make it easier than probabilities to determine payoffs. Odds in favor of an event are the ratio of the probability of the event occurring to the probability of the event not occurring. So, for example, how many females are there in here right now? 1, 2, 3, 4, 5, 6, 7, 8. Do we have 8 females? And how many males? 1, 2, 3, 4, 5, 6, 7. Oh, I guess if you include me, I didn't count me. No. So 10 females. So the odds in favor of females is equal to 10 to 7. See? So odds in favor of females is 10 to 7.
Oh, yes. Wow, that was those numbers matched real well.
What's that?
The number 1.
Oh my!
Wait, is it? Not 10 to 7. What's the probability of A happening 10 over 17?
Yes. The probability of A is, but we're gonna do the long.
No, but you want
I get it's 2018 and there's others.
no, but you want to find the point. It doesn't matter. But I'm just using the numbers.
No, A naught is strictly just the guys in this spot. If A is the girls, A naught is the
Well, the odds against females is the reciprocal, or the odds in favor of males. Are you ready? Okay. The odds in favor of A are the probability of A divided by the probability of A naught, or it's the number of ways A occurs divided by the number of ways A does not occur. Okay? So given that the odds in favor of A are probability of A, so using the formula 10 over 7 is equal to the probability of A all over 1 minus the probability of A, or the probability of A naught. So now we cross multiply. 10 minus 10 PA is equal to 7 PA, right? And then we can move that over and move that over. So minus 17 PA equals minus 10. So the probability of A is 10 over 17. And so we could use this formula. So the probability of A is H over H plus K. If the odds in favor of A is equal to H over K, the probability of A is, so we could have done this, probability of A equals H 7, no, I'm looking at the wrong one. I should be looking at this, is 10 over 10 plus 7, and that's 10 over 17. Just a nice shortcut, okay? Okay. If we know the probability of A is this, the probability of A is this, find the odds in favor of A. So odds in favor of A is equal to the probability of A over the probability of A naught, or 1 minus the probability of A. So this is equal to 10 over 13 over 1 minus 10 over 13. So that is equal to 10 over 13. 13 over 13 minus 10 over 13 is 3 over 13. And that is equal to 10 to 3. So if you notice, the probability for A is quite high, so the odds in favor of A is 10 to 3. It is also quite high. Now, let's get into the gambling. Odds in favor of A are the amount wagered over the amount won. Okay, the odds in favor of the Argonauts winning the Grey Cup are 10 to 7. What would be the winnings if a $2 bet is placed and the Argos win? Okay, so it's just a matter of the formula. Odds in favor of Argonauts winning are 10 to 7. And what would be the winnings? Okay, so the amount wagered is $2, and the winning we can calculate. Well, you get the $2 back, but then he wins $1.40 on top of it.
So is it you put $2 in, you get $1.40 back in total, or $2 in and you get $3.40?
You know,
$1.40 back.
well, what about the he's out 60 cents then?
Yeah, that's why the odds. Because the odds are that they're gonna win. 10 to 7 means you have to put in $10, and if they win, you get $7 back. That's why you don't.
You're paying to play the game. But you never come out ahead?
Only in this case, but usually when there's underdogs, if you put a bet on 20 to 1.
Or 1 to 20.
1 to 20.
If you put in $1, you get
Then
$20
yeah,
back.
if they win. But
Oh.
they have bad odds because they're not favorites.
See, I don't gamble, so I was never sure.
Wait, so in this case, do you get
You get $1.40 back. Only $1.40.
Like, so you lose money, what's the point?
Yeah, well, what's the point of betting on a team
What's the
that's
point of
going
betting
to
on
be
the Warriors
winning?
when they're gonna win?
Because this is Argonauts have a 10 to 7 chance of winning.
yeah?
Only bet when you know the
Wait, so is it like you would only bet when you know the underdog's gonna win? Or like
Yeah, or if you feel like they'll win.
yeah. So no, but I'm saying if you bet on the one with higher favorites, you're gonna lose money
Yeah.
most of the time.
Yes.
What's the point of betting?
Because the odds of them winning are so high.
Yeah, you lose money just to pay to play.
You lose money even if they win.
So
Because
what
everyone believes they're gonna win.
So when would you ever make money in this case?
In this case, you can never make money off the Argonauts. You can make money on any other team.
Any other team but the Argonauts in this case.
Yeah. So you want any other team to win.
Gotcha.
What?
Normally they don't tell you the odds.
They do.
They do.
Good.
Yeah.
You're essentially you're betting on a team that you know is gonna
So then they,
so you're losing money.
so then nobody's gonna bet for the.
I can tell you.
If you do the math, no one's gonna bet for the Argonauts. If you
It's
don't,
like no one's gonna bet on both teams because they know they're gonna win.
I'm thoroughly.
Okay, number B.
That's why betting is also illegal.
How much money must one wager in order to win $20? So 10 to 7 equals wager over 20. Oh, so now we can figure out, does it depend on the wager? Oh, 200 equals 7 times the wager. So wager is equal to 200 over 7.
So you have to put in 20. That's a feels bad, dude.
It was 200.
It was it.
No, it's 20. Oh, you're right. I'm getting mixed up. Okay.
Guys, don't gamble. That's a movie story.
Well, no, so no, yeah. So the thing is, it's illegal to you don't bet on Argonauts and stuff like officially. Like that's not a thing. Okay. That's why it's also those
Okay, good. Shh. Okay, stop, please. Okay. The odds against a university graduate, odds against are the reciprocal of odds in favor. So odds against a university graduate being employed within 1 year after graduation is estimated. So odds against employment is equal to 1 to 20. What's the odds for employment? What's the odds in favor of employment? 20 to 1. It's the reciprocal. Odds are always a ratio. Don't put it in decimal form. It's either a ratio or a fraction. Do not put it in decimal form. Part B. Does anyone care to guess what the probability of being employed is? You can use your handy dandy formula, right? That's all, folks. Are there any questions? Thank you for the enlightenment on betting.